Okay, ladies and gentlemen, today you are finally getting your lesson on how to use the slope formula to calculate slope between 2 points. First thing you're going to notice is our formula right here. This tells us that we are taking our second y value minus our first, and our second x value minus our first. Those little 2's and 1's, guys, are called subscripts. Subscripts are not the same as exponents. Exponents have you actually do some multiplication. Those are just ways to identify your first point from your second point. We'll talk about that in a second. The other thing you'll notice about this note sheet is I often use the letter M when I'm talking about my slope formula. That's because M is the letter in math that we end up using a lot because we like to simplify things. M actually comes from the French word monter. Monter means to rise or climb, okay? And if you remember, we've been working with slope where we look at the rise and the run to talk about the ratio of the vertical component to the horizontal component. So it's really the same thing. It's just somebody decided to use M, so it's short for slope. So now that you know that. Now, this side of the note sheet, what we're going to be doing is we're going to be taking 2 points that we found on this line right here. Notice it's heading downhill, so it's nice negative. We will end up with a negative value for our slope. But guys, instead of doing it with our slope triangle like we've been practicing, I want to show you how you can do it without the graph. You can actually pick up your 2 points. Our first point is over here. It's labeled as negative 6, 8. And our second point is the point 0, 4. And I always tell students we need to label our points before we even begin to use our formula. Because we need to remember each point is made up of an x value and a y value. Now guys, since this is your first point, I'm going to call this x1, y1. And since this is your second point, which also has x and y values, we're going to call x2, y2. Make sure you draw those little numbers down below, not up above like an exponent would look. Again, these are not exponents. So guys, now that you have your 2 points labeled, we're going to go ahead and use our slope formula. This part here, remember, is just talking about your rise. How far is it from bottom to top if I had to draw my slope triangle? And again, you could do that using this formula. So if I look at my formula, it wants my y2, which in our case is 4, to subtract my y1, which is 8. Okay, and that's all you do at first. You just jot down what values are what. On the bottom of the fraction, remember we're looking at the run, which is the horizontal distance between the 2 points. The horizontal distance is really the distance between our x's. So see how x2 we have labeled as 0, minus x1, which we have labeled as negative 6. Guys, this part's really important. The formula needs you to subtract the values that we have. So that means sometimes subtracting a negative 6. So if you remember from last year, you could do your keep, change to make the math a little bit easier for you, or you could just type this in your calculator. 4 minus 8 is the same thing as 4 plus negative 8, so that's negative 4. And on the bottom, 0 plus positive 6 is 6. We always reduce our slope fractions. And what we're going to do with this first couple of questions is we're going to go ahead and we're going to draw our slope triangles, and we're going to verify that that really is the slope that we agree upon if we had done it with our formula or if we had done it with our slope triangle. So remember, slope is looking at the rise compared to the run. We definitely have a rise of 4, but it's going downhill, so we mark it negative. And we have a run of 6. So guys, this just verifies that we don't have to always draw on the graph with a slope triangle if we're interested in the slope. We can find the rise and run a different way, and that's with using this new formula. So down at the bottom, for our second example, we have to pick out our points first. So as you can see, one of our points is right here, 0, negative 2, and our other point is right here, 3, 7. So once you have your points available, guys, remember you're going to label them. This is my first point, so we're calling it x1, y1, using those little numbers which are called subscripts. This is my second point, so it also contains x and y values, but because it's my second point, I'm calling it x2, y2. Labeling your points is key because now you're going to plug it into this formula. The formula wants you to take your y2, your second y value, which is 7, and subtract your first y value, guys, which is negative 2. So here we go, having minus and negative again. And then x2, which is 3, minus our x1, which is 0. So once again, since we have subtraction, we're going to be very careful with our keep, change, change. And if we need to, we can subtract our fraction, or reduce our fraction. So over here on the graph, we're going to take one last time to review that the slope triangle really does give us a slope that matches what we found with our formula. So in this slope triangle, 1, 2, 3, 4, 5, 6, 7, 8, 9, it is a rise of 9, and it is a run of 3. So 9 over 3 reduces. So guys, the slope formula gives you a way to find the slope between your points that doesn't involve graphing and doesn't involve counting your boxes. Okay, you do have to be careful in how you label your points, how you plug them into the formula, and of course you have to be careful with your calculations with all our negative numbers. But this is what we're going to work on, and this is what we're going to practice. So on the bottom, I just thought we would fill in this little starburst thing is to remember to always reduce our fraction. And as always, be really, really careful with your negatives. So on the other side, there's a couple practice problems that we'll do together, and then I'll have you pause the video and try some on your own. The formula, again, is at the top of your paper. We always need that handy. And you'll notice I didn't give you any graphs to worry about on this one. We're just going to focus on doing these using the formula. So that means the first step is labeling. This is my first point. Points always have an x and a y, but this is my first point, so that's why you're going to label it x1, y1. This is my second point, so you're going to label it x2, y2. And we're going to get ready to plug into our formula. See how the formula always says y2 minus y1. So here's y2, 9. Here's y1. Okay, so the first part is done, and now we're going to do the bottom of the fraction. x2 minus x1. So if you do your math correctly, I don't think we have to do any funny sign changes. We have a slope of positive 2. If we took the time to get out graph paper to plot these 2 points, we would find that the slope between the 2 points has a nice set of slope triangles that kind of look like stairs. They'd always be up 2 over 1, or we could draw a bigger one that looked like up 4 over 2. And that would be the steepness of the line connecting our 2 points, so we're good. Second question on the practice side. Once again, you're labeling x1, y1, x2, y2. Be careful. Every point has an x and a y. This is just our first and our second to keep it straight. Formula again wants my y2 minus my y1, so I'm going to be doing 1 minus 5. And the bottom of the fraction is always x2 minus x1. This time I'm going to do some sign changes because it'll make it easier for me to do that. 1 plus negative 5 is negative 4. 8 plus negative 2 is 6, and I can reduce my fraction, so we should. Notice it comes out negative. If we had plotted these 2 points, it would show a negative slope between them. Nice negative, it would be heading downhill. So guys, what I want you to try, there's 3 more practice problems at the bottom. I want you to start out by labeling them, and I want you to start out plugging them into the formula so you can get some practice on your own. So at this point, you're going to pause the video. You're going to try them, and then when you're done trying them, you're going to play the rest of this video so you can check your work. Okay, by now you should have practiced the last 3 questions. So to review, we're labeling our points x1, y1, x2, y2. We're plugging into our slope formula, which compares our y's first, which gives us our rise, and then it compares the run, which in our case is our x's or our horizontal values. So in this case, negative 8 minus 2, I turned it into plus a negative 2, did my sign change, and then on the bottom we have 3 minus a negative 3. So if we do our calculations right, we end up with negative 10 on top, 6 on the bottom, and we reduce. For the next one, it's kind of interesting that we have the same x value. So when you go into the formula, 7 minus 7, or if I change the sign, 7 plus negative 7, does give you a 0 in the denominator. In this case, it didn't matter what was in our numerator, guys. Whatever you have divided by 0 is actually mathematically impossible. Remember, we talked about this. You cannot divide by 0, so that means we have a set of points that would give us a undefined slope. If we graph these points, 7, 9 would be right on top of the point 7, 4, and when they connect, they would be a perfectly vertical line. So be careful when you end up with zeros because it might be undefined. And with the bottom one, like we saw, this time the y values are both 4. So when we plugged in our y values, 4 minus 4, or if you do your sign change, 4 plus -4, you end up getting a 0 on top of your fraction. Now guys, mathematically this is different because we could take 0 and divide by 2. It just means that everybody gets 0. And the reason this is different from the undefined, if you think about where these points are graphed, -3, 4 is right here, and -1, 4 is horizontally right next to each other, these points are. So they will connect to form a line that is perfectly straight across or horizontal, which means 0 slope. So guys, now that you've had some practice and you understand how we can use the slope formula, you're going to cut on the dotted line, and you're going to go ahead and put it into your notebook. And then I have some extra practice problems for you to try. Have a good day.